Hello, good day. Today we'll continue our tutorial series on how to apply or use RCC11 element design to design structural elements. We'll be looking at column design. To begin, I click on the column tab. At the very top here, you could see this is for column design. The spreadsheet designs to BS8110. We have two major sections, the input section and the output section. As you can see, the input section is where we enter data. When we look over here, the operating instruction says enter data in blue cells only. So this is where we enter all the data for the column. And then down here, you can see the calculations, and then you can see the output. The output is where the result, the reinforcement is stated. The advantage of using this spreadsheet program is to help you to figure out yourself if what you are doing is right and to pinpoint where there are problems. So the spreadsheet program is very open. You can see all the calculations, all the iterations it is doing to arrive at the final results. Sometimes when you don't understand some values here, that is under the calculation, you can go here and check it out. So let's begin. Now we'll not be treating any example, but I'll be showing you how you can change these values in the input section and review your results here. Now, if you notice, look at this input result, you find out that in the output, there is no design because there is an error. Now you can see the error, no good, centers too small, which means that the spreadsheet program not only check if the column section is adequate, it also checks for spacing of the reinforcement. So if there is any error at all, it will not provide answers. Let's explain the input section. We have here the axial load. The axial load is the load that the column is carrying. That is the load from the slab, from the beams, and from the structure above. The moment is the moment the column is subjected to. The height is the sectional height of the column. And we have the breadth, the sectional width of the column. So the height also can be like the length, the sectional length of the column, and B, the sectional breadth of the column. Now we have maximum bar. The maximum bar is the diameter of the reinforcement bar that you prefer to use in the design. And then we have the cover to reinforcement. FCU is the strength of the concrete. Fy is the strength of the steel. Then we have the factor of safety for steel and the factor of safety for concrete. Now the links for the column is set at 8 mm. Now all these values, you can change them based on your design calculations. So let's play around with this input. Let's say axial load 600. Let me reduce the moment to 30. Then let me change the height and the breadth of the column to 225, 225. And then the maximum bar, let's say 16. You notice how the calculations are changing. So let's leave the cover to link as 30. And let's leave all this one here, but we can change the link here to 8. You can see, if you look at here, the program is recommending a link size of 6 mm. Let's obey that. You see, as we were changing the parameters in the input section, so also the calculations is being updated. And one thing you will notice is now there is no more errors. And then we have an output. The output says, provide 2T16 top and bottom, 402 millimeters squared. And we have links, provide T6 at 175. When we scroll down, it tells us here that provide T6 at 175 in 2 legs. So it tells us the type of link, 2 legs. So this is how generally you can use this spreadsheet program to analyze your column. Prior to using this program, you would have determined your axial load and any moment acting on the column. This can be done using another spreadsheet program that does structural analysis or from your own manual calculation. So taking a little look about what is being calculated here. When you look at this one, 6.67 FCU over GM, it means the design concrete stress. This simply means 0.67 FCU divided by the factor of safety for concrete. Similarly, we have Fy over Gm, which refers to the design steel stress, which is 460 divided by 1.05. So here is effective depth as per compression, and D here is effective depth as per tension. That means from the top of the compression face of the column to half of diameter of reinforcement of the steel. Now let's see a diagram that will explain this further to us. This design provide 4T16. So these are the 4T16 bars. Here you see the concrete cover, which is equal to 30 mm, and we see the links, two legs, 6 mm diameter. So, and then we have the vertical reinforcement, which I've said earlier, that is 4T16. So you can see the vertical spacing of links is 175 mm. So this diagram is the result of the output. The result of the design is what is shown in this diagram. So let me close it. Now, before I round up, this program is a free open source, which means you can modify and adapt it to your own design needs. Going over here to notes, you could see is a public release version. So the advantage of this is you can see your results, you can scrutinize the calculations. Calculations are further explained here. You can see the iteration used in the design here. You can see summary of the results here. You can see the checks that have been made and so on. So if there is any error, it will notify you of the error and design output will not be provided. So this is an introduction to using RCC11 for column design. In the next video on column design, we'll be treating worked examples from standard textbook and also from a structural plan of a real-life project. Thanks for watching this video. Like and subscribe for more civil engineering tutorials.